其实就是把微分方程转成代数方程。对，就是特征方程式。在控制学里头，这个就叫做 characteristic equation。characteristic equation 就是特征方程式，特征方程式就是多项方程式 ，right? So in solving ordinary differential equation or in solving dynamic systems 在控制领域里头 because dynamic is good, we change this dynamic equation right into Laplace, right? And Laplace into algebraic equation. Algebraic equation is polynomial equation. So you're actually solving polynomial equation to get the answer for your Laplace, right? You're solving characteristic equation, which is exactly solving fx equal to 0 for polynomial, right? Okay? So the truth is that in automatic control, 因为你们要考试嘛 in automatic control, because you need to do exam, right? So they will always give you problems, simple problems like second order, right? If you are solving second order, easy, right? 如果是二阶方程式，代数二阶方程式，背公式就好了嘛 ，right? But if it is higher order than cubic, than fourth power, higher and higher, you're not able to solve it. 所以考试不会考你三阶或四阶啊，因为你要解不出来啊，你知道为什么？四阶以上你就解不出来。但是对数值方法来讲，我们等一下看到完全一样。Okay, so now this is important because I will show you very important how do we solve this problem, because we know this algebraic equation, just like I showed here, if n larger than 4, you do not have an analytical solution. You can only rely on numerical solution. So it's very important. We need to learn how to solve this by eigenvalue problem. Numerical solution by eigenvalue problem. So how and why? Let me show you. Okay? To solve this problem, let's take a look. First, remember last class I showed you this. I said solving this is y to this, right? Sense not, right? We show you that we let y1 equal to y, remember? First one. And then that's y2 equals to y dot, right? So that equals what? Equals y, because y dot is y1 dot, right? And then y3 is y double dot, right? And y double dot is y1 dot, right? Sorry, y2 dot, right? y2 dot, right? Is that correct? And we say y3 dot equals y triple prime, right? And this one from here, let's assume this is 0, right? Then we have minus a y double prime minus b y prime minus cy, right? Like this. And then this one, remember, equals minus a y double prime here, y double prime here. That's y3, right? And minus by prime, y prime is here, right? That's y2, by2. And minus cy, y1, that's cy1, right? Okay. So from here, we actually have, let me do this first. y1 dot equals y2 dot equals y3 dot equals, let's see, y1 dot here, that's y2. And y2 dot here is y3. And y3 dot here, that's this. So that's minus a y3 minus b y2 minus c y1, right? Okay? Now, take a look at this. This is important that we have y1 dot, y2 dot, y3 dot. Using this, and we put into matrix form. Here's the crucial part. Here is y1, y2, and y3. And here is 0, 1, 0, because 0 is y2 here. And the second one is 0, 0, 1, right? That's y3 here. And the third row is minus c, minus b, minus a, right? So we put it into a matrix form, okay? So after putting it into a matrix form, very important, the y dot, if we take Laplace, what would happen? We would have s, y, no dot, right? Because y dot, right? Taking sy, you know, y dot taking Laplace is sy, right? This is here. And equals, let's call this A matrix. So sy vector equals a y vector. Okay? Sometimes we don't use y, we use x. If I replace y, let x equals y. 其实我只是要让你感觉更像而已的哈。If we use x equals y, this would be sx equals ax, right? Remember this? Eigenvalue problem. Because remember, ax equals lambda x is eigenvalue problem, remember? Now, s is lambda here, right? Characteristic equation, s is lambda, right? So this one is actually same as this. No matter you use y or x, because I just use x, the reason I want to show you, you remember this is eigenvalue problem. So I show you now, this can be solved because eigenvalue problem 我们已经教过了嘛 right? We already teach you how to solve eigenvalue problem, right? Yeah. This one is a minus lambda I x equal to 0, right? And so the determinant, right? The determinant a minus lambda I needs to be 0, right? Determinant, right? Determinant. And so now this one, take a look. A minus lambda I, take a look. Put it into this. Lambda now is the same as s, right? Right? So to put this into this form, what we have is a minus lambda I equal to 0, just like a minus si here. A minus si equal to 0, right? Lambda just s. So from this equation, you will have this. Minus s, 1, 0. 0, minus s, 1. Minus c, minus b, minus a, minus s. This is equal to 0. 对吧？是不是？ So, to solve this equation will become a polynomial equation. Right? So actually, we are solving this polynomial equation. This is our polynomial equation. 这是我们原来的多项式方程式 polynomial equation. 我们把它转变成了 eigenvalue problem. Because you are not really solving this. You will solve this using the method we teach, the numerical method we teach. Remember? 是什么方法？我们不是教过吗？有没有？还记得吗？忘掉了，我们讲那个最重要的方法，怎么样去解 eigenvalue problem？You remember when we teach you how to solve eigenvalue problem？ 啊 ？No, not Smith。我们不是在讲说解 ax 等于 b 的时候，解 x 等于 b 的时候，有什么方法 ？LU decomposition。再来呢 ？QR decomposition，right？ 对 ，SVD， 但是 SVD 也是根据 QR 来算的，所以解这个的时候是用 QR 演算法，还记得吗 ？QR algorithm，remember？ 第一次其实不好去考，不行，下次要考。Okay, 上次 we only in the first midterm we only give you test on QR decomposition, right? And so QR can be used to solve eigenvalue problem. So using QR algorithm, then we can solve this, right? So with QR, we can solve eigenvalue problem, and then we solve this. We come back here, we solve this. You understand? Okay. So now everything is connected. 从我们一开始学期初的时候解这个方程式，我们就说那个东西不能解。到我们现在呢，发现其实我们是可以解的。我们用 QR 演算法可以解 eigenvalue problem。eigenvalue problem 回来就解这个多项式的等于零的问题。Okay. So now let me repeat it again. We found out that in the beginning of this class, we say we can use Newton-Raphson method or use a bracket method to solve f of x equal to 0. And then we told you that for a polynomial equation, if n higher than 4, there is no analytical solution. We're not able to solve an analytical solution, right? And now we found out that indeed we can use numerical method. We can use QR iteration and QR algorithm to solve eigenvalue problem, because now we reduce this problem. Today, we show you the higher order differential equation is actually the polynomial equation or higher order algebraic equation. We can bring this to this form. 我们可以把这个微分方程式变成这个 form, and this form will get into this matrix shape, and this matrix shape is actually eigenvalue problem. So all we need to do is just solve this eigenvalue problem of this A matrix. Then we are solving this. 我们就解了它的根，问题就解出来了。这样了解了吗？这样了解了吗？ So this is very important. Yeah. And also, for you guys who are, you remember you learned automatic control. 你们有学那个控制吗？ You guys belong to the control group, right? You remember in control theory, if you are solving a problem like this in control, if this is, let's say this is ft, and this is yt. Now in control, we call this plant, right? And how do we represent this plant? We use Laplace, right? 通常我们是用拉普拉斯嘛。So if we have a problem like this, and this is the transfer function, remember? Laplace transfer function, remember? In control, this is the input, so you have, then this becomes fs, right? And this becomes ys, right? And then we say ts equals ys divided by fs, right? Right? 这不就是 control 的东西吗 ？Right? Control 的东西。But this is what we call classical control. Do you remember? classical control. What about modern control? 你们控制有学控制1、控制2吗？啊？控制2没修？那控制2有教 modern control 吗？还是控制1就教 modern control？ 控制2有教一点，控制1没有教。Okay. So maybe you learn modern control in control 2. In our department, I think we have control 1 as required courses, right? 那个必修吧，控制1是必修嘛，控制2也是必修吗？控制2是 selective, right? So control 1 is required. You must take the class. Control 2 is selective. You don't need to select the class, right? But usually modern control is taught in control 2, maybe. So this is what we call modern control. Now, modern control will take this form into another form. Do you remember? Modern control will take this form into x dot equals ax plus bu, and y equals cx plus du. Do you remember? 看过这个吧？看过这个吧？ Right? And then this is called modern control, right? Now, normally, 通常来讲 normally, you would think this is easy, this is more difficult. Because modern control usually means more difficult, right? It's called modern control. And that's why usually in the control 2 class. And you would think this is easy and this is difficult, right? But let me tell you, from the numerical method point of view, 从数值方法的角度来看 this is actually easier than this. This is easier than this. Why is this easier than this? Let me tell you. Because in this, you have to deal with Laplace transform all the time, right? You have to, either using your head or whatever to do Laplace transform. But with no Laplace transform, you have to look up the table and everything. And it's difficult. But when we convert a problem like this into modern control in this format, this becomes just like our Euler method. This becomes like our Euler method, right? And this becomes very easy for us. Why? Let's take a look. Isn't this Euler method? If we can turn a control problem from this to this, let's see, x dot equals ax plus bu. Now u is not a vector because u is input, only one input, right? One single input. And then y is the result of cx plus du. Okay? Now notice, only differentiation is here. So you can solve, if you solve this equation to get your answer, x, and then you plug in here, then you get your y solution. You get your y solution, right? So this means we only need to solve this problem, and then we can get the solution easily. How do we solve the problem? Actually, quite easy. Let's take a look at this here. Let's say if we have like this problem, 3 by 3, 3 by 3, which is this? Which is this? Notice, this exactly is this, except we plus bu here, we plus bu here. So if we have this, it means x1, x1 dot, x2 dot, x3 dot equals x1, x2, x3 plus in this case, let's just say the third equation, this one, because this one the equation is here, would plus u, and this 0, 0, maybe here we would have this ft, which is here, ft here, and so this last equation would time this one will be ft here, 0, 0, because the last equation y3 or x3 here is the last equation, which is this, right? Which is this, and then plus ft. So we will have this here. Now, a is actually 0, 1, 0, 0, 0, 1, minus c minus b minus a. In this case, for this problem, is this. And this is linear. This is linear. So how do you solve this? Very simple, using Euler method, right? 用我们 Euler method. 这个 equation, the first equation becomes x1 I plus 1 equals x1 times here, that's x2, right? So here is actually no x1. This is because xi plus 1, right? And 这个公式跑到这里来乘上去，好，它只有一个 x2， 这边移过来这 x2， 所以是 x2i， right？ 我这边有点想错误啊，这边应该是这边讲错，这边应该是 x1i plus h times here, and here includes this, right? So this is x2i here, and plus ftI, right? 这个是指乘它加上这个这边没有，这边讲错了，这边是0，所以 here 0. Sorry, this is 0 because here is nothing. Here is 0, right? And the second equation, x2i plus 1 equals x2i plus h times the bracket. And the bracket, the second one, times this. And only x3, because this is 0, 0, 1, only x3. x3 plus x3i plus 0, because here is also 0. Then the third one, x3i plus 1 equals x3i plus h times, now notice here, more complicated, because we have minus cx1i minus bx2i and minus ax3i and plus ft times u, and u is 1 here, u is ft, okay, so this is here. So now we have 3 Euler equations, 就是我们今天开始教的 Euler equations. Then we begin to do the iteration, starts from 0, and then h1, h2, h3, right? So I start from 1, 2, all the way to your iteration. 你要多少都可以，对不对？ So this is called initial value problem because it starts from 0. 0 is the initial value. 因为 i 等于0的时候，这个 x1 0、x2 0、x3 0就是它的 initial value， 你的微分方程的 initial value。所以你就一直迭代到你要的 xn 为止，到你的 xn。So this starts from 0 to n iteration, and every iteration step is h。 每一个小步骤0.001秒、0.002秒、0.03秒，你就可以这样算。Okay, so here I show you, this is very important, that by using modern control concept like this, you can use what we teach today, Euler equation, to get the numerical solution of your complicated problem. No matter how complicated, no matter whether it's with nonlinear or not, you can use this approach. And for control problems, even with this format, model control, this is still linear, 因为这个还是线性的。我们数值方法可以做非线性，但是这个还是线性而已。This is still linear, okay? And we know model control, this is very important to solve a lot of model control problems. So the summary or the conclusion is that you can use numerical method. You can do this simulation to do any of the model control or classic control problem as long as they are either linear or nonlinear. You can do both. This may be new to you, but this is very important because we're connecting what we showed today. 课本上东西很简单 all the 方法很简单 which is very simple. But we connect these to real application for solving dynamic systems or solving automatic control problems. Okay? Now, with that, I'm going to show you the program. 电脑程式